In Chapter 1, Section 1.4, that's a really interesting section because it just looks at ways that statistics is abused, and it'll get you thinking about different things that you've maybe encountered in newspapers or magazines or online, and it'll make you start to question whether the statistics is really accurate or not. So look for things to watch for. One of the ways that statistics can be abused is when individuals who are conducting the research use voluntary response samples. So we've all been walking in the mall and we've walked past those people that try to grab us and get us to participate in a survey. That is a situation where it's a voluntary response. It's also called self-selected, and so they don't always get a really accurate sample of the population in those because many people can't participate. So samples where people choose to be part of the sample are voluntary, and the problem with this and the reason why it creates bias is that many times only the people who really participate and give their responses are those who have really strong opinions about it, or people who actually have the time to respond. So you'll get responses from people who are strongly agree with it or very strongly disagree. You don't really get a lot of responses from those neutral people. Another thing to watch for is when very small samples are used. Those tend to give you bad results, and the statistics is not accurate. Another really common thing is misleading graphs. Look really carefully at the graph and see if it really starts at 0, because then the height of the graph can be misleading. Here's an example where we have two different diagrams. But the finances seem to be a little bit misleading, and so a lot of times to make graphs pop out and be interesting, people might use pictures, and these are called pictographs. So which of these two graphs suggests a bigger increase in savings? Well, just looking at the pictures, you might actually select the second graph where you see that the money bags are used as pictures, and you can see that from July to August, oh my goodness, how much money did that increase by? And you'll see that it just looks so much bigger, whereas if you look at the typical bar graph used in the first example, it increases, but it doesn't look that big. So the second graph actually suggests a bigger increase in savings. And that's because if you look at it, not only is the height increasing, but also the area. So the whole volume is getting larger, and that's an inaccurate picture of the true finances. Here's a list of some other things to look out for. It's definitely not a conclusive list, so you'll just need to read your book for more. But miscalculated percentages are an abuse of statistics. Loaded questions. So if you take a survey and the question is worded in a way to get you to respond a certain way, that's a loaded question. So here's a couple of examples of ways to word things. And so the first one says, should the president have the line item veto to eliminate waste? Well, sure, that sounds good. We want to eliminate waste, and so 97% of the people responded yes. But if we word the question a little bit differently, should the president have the line item veto or not? 57% said yes. So you can see that when we load the question to elicit a certain response, that really affects the results and it creates bias. Ordering questions is important, so look at example 7 on page 22 in your book. Also, if the surveys have a large refusal rate, so if they sent out 10,000 surveys that got only 2,000 back, then your results can be very biased because of that. So look out for response rates. Also, look for overly precise numbers. If we publish a number and we say that there are 325,670,000 people in a certain country, well, that's really precise, and so sometimes that means people are guesstimating. It's better to round off those numbers. And then if you read the section, you'll see a lot more examples of ways statistics can be abused. Let's look at page 23 in your book, example 6, and we want to use critical thinking to come up with a better conclusion. And so the situation is data published in USA Today were used to show that there is a correlation between the number of times songs are played and the number of times that songs are purchased. So here's the conclusion. They concluded that increasing the times that songs are played on radio stations causes sales to increase. You have to be really careful here with cause and effect. We can't really say that correlation implies causation. So these two, we're showing that these two things are associated somehow, but it's not necessarily being caused by the other. So maybe the reason more songs are being purchased could be just because of the popularity of that particular song artist and the quality of the music, and not because it's being played a lot of times. In a study of cold symptoms, every one of the study subjects with a cold was found to be improved 2 weeks after taking ginger pills. Now let's think about the last time we had a cold, and how long does it take pretty much to get over a cold completely? Well, if you think about it, it takes a week to 2 weeks. So do you really think the ginger pills were causing the colds to go away? I don't think so. So colds normally last less than 2 weeks regardless of medication taken or not taken. So, you have to be really careful about these types of claims that you might see being. And here's on page 24, example 12. After the national census was conducted, the Poughkeepsie Journal ran this front page headline: 281,421,906 in America. So what's wrong with this headline? Well, if you paid attention earlier, this headline is a really, really precise number. And so when they use great precision, usually that suggests that something is wrong there because, population counts are always an estimate. So they should have rounded off that number so that it's not too precise. And here's example 10 on page 24. AOL ran a survey of its users and asked if they preferred a real Christmas tree or a fake one. AOL received 7,073 responses, and 4,650 of them preferred a real tree. Given that 4,650 is 66% of the 7,073 responses, can we conclude that about 66% of the people who observe Christmas prefer a real tree? So notice here that we are transitioning from the population of AOL subscribers and we're saying 66% of the people. Well, this sample is a voluntary response sample. So we need to remember that and mention that, and remember that it might not reflect the opinions of everybody involved. So that's the problem with that type of a conclusion. On page 18, let's look at example 16. The author received a survey from the investment firm of Merrill Lynch. It was designed to gauge his satisfaction as a client, and it had specific questions for rating the author's personal financial consultant. The cover letter included this statement: "Your responses are extremely valuable to your financial consultant, Russell R. Smith, and to Merrill Lynch. We will share your name and response with your financial consultant." So what is wrong with this survey? Well, the first thing I think of is, this is the person who handles my money. Why would I want to share with that person if I wasn't really happy with my results? Because they're handling my money. So what's wrong with this survey? Well, people might be reluctant to give their name and a bad rating and for fear of retaliation. So they should have, this is kind of a loaded question, they should have really come about a different way of getting the survey results back.